let's try this again. This is number 9. I don't know if it's page 1 or 2, whichever. So again, what we had stated is if you're starting with atoms or looking for atoms or starting with particles, looking for it, you'd be using Avogadro's number. And the label for Avogadro's number would be what? Yeah. Everything you said is correct. That's the number. What's the label? Atoms. Yeah. I mean, no, that's fine. That's how we learn. That's how we grow. Okay. So how do we get that to cancel in the next step? Put it on the bottom, because we correctly said that for every part of Avogadro's number, that's our label, that's our conversion, and there's that many atoms in 1 what of a substance? 1 mole of a substance. That's correct. So in this case, it's moles of NiCl2. Okay? So what has happened so far to these atoms? They're gone. We're in moles of nickel chloride, so around the home stretch. How does that cancel? Put it on the bottom. For every mole of nickel chloride, you get what? What would go on top? Grams, and that's what we're looking for. Okay? So 50, is it 130, 140, something like that? $129.59. Okay, these are gone. You're in grams of nickel chloride. That's what we're looking for. So, punching this into our calculator. Okay. Go ahead and punch in 9.061. Oops, I didn't do that right. 9.6103. Okay, there again, get your exponent function in there, 27. Okay, what would you do? What would your next step be? Multiply by 129. Remember, if they're next to each other on top, you multiply. On the bottom, you divide by that. So, 129.59. Okay, and then that should give you 1.25 times 10 to the 30th, correct? That's not the answer. Okay, so we want to divide that answer by Avogadro's number. And it might spit out a scientific notation number, but it should be 2,068,081 or 2.07 times 10 to the 1, 2, 3, 4, 5, 6, times 10 to the 7th. 10 to the 6th, well, maybe I'm holding these too close. Times 10 to the 6th, yes. Is anyone having to change that, or is that what you had? That's what we had, wasn't it? What about talking about it? Oh, okay. Fair enough. Okay, let me
I've used it in scientific mode and in regular, and I put parentheses in it just to get that. But I got the 1.24 divide by that.
Okay, so I wonder.
It's not regular on like the regular mode. I had it on scientific.
And that's fine. you need to put that in parentheses. That would give you your 2.06 times 10 to the 6th. What I would suggest, don't do second answer or take the answer. You need to manually input the answer that you get, put it in parentheses, then divide by Avogadro's number. That has to be in parentheses too. So one of the things that you might want to start thinking about is using a different calculator, which is fine. I'm not saying there's anything wrong with that calculator. It's just programmed a little differently than everyone else's in here. So that's the decision that you're going to have to make. Okay, I think it's a little easier on one like Lane's or Olivia's or whether it's Weston or Noah, whichever, or any, yeah, whichever, or even this one. So go ahead and make that determination. All right, so if that is it, okay, please make sure your names are on them and stapled. And does anyone need the stapler? Okay. All right, thank you, thank you. Is this 2 of them? Oh, aha. Thank you, thank you. Got my answer key. Awesome. See? Uh, Now, we've had this conversation before. You're about ready to serve. This is going to be bad. You don't know that.
Yeah, you do.
Well, you know that in volleyball because you don't know that in chemistry. Or do you? I don't know. Well, you can't be 100% sure it's going to land where you want over the net either. All right. Okay, fair enough. Fair enough. Okay, thank you. Thank you. Thank you, thank you. Thank you. All right. Just maybe a good reminder. It can happen from time to time. It gets graded. It gets handed back to you. There's a grade on it, but it says missing in the grade book. It happens. Just a simple fix. Just say, I've got it right here. It's graded. Sometimes you don't want to throw any papers away until you know it's in the grade book. It can be misplaced on my end. Sometimes some of these papers stick together because of the staples, and it gets missed. Mistakes can happen, and then get passed back. Say, well, I had it, but it's not graded on there. So just keep that in mind. Okay. So for rest of the time, there's a you want to call them review problems. We'll take a look at, and want to get that confidence level up. Just like how Minnesota's going to do this year in football or baseball. Uh-huh. You waxing?
Yeah.
Okay. Okay. I've been doing this job a long time. I can honestly say I've never seen that before. You guys gonna volunteer? Do what they're doing. You'll pass? All right. Oh. Okay. Is that everybody? Okay. The reason I said the third problem down, it might look, oh my gosh, density. Oh, that's terrible. Maybe yes, maybe no. Okay. The world famous Hope Diamond has a mass of 1451.38 grams and a volume of 715.37 cubic centimeters. What is the density of the diamond? Okay, there's a formula for density, and that is it's equal to the mass over the volume. Okay, so in this problem, and then what else we are given is 715. If it's cubic centimeters, do you think that's a density? Is that a mass, or is that a volume? Cubic centimeters. It's a volume. That's correct. So that's this guy. 715.37. You could say cubic centimeters cc. This means the same thing. All right. So hopefully this problem doesn't look that difficult, does it? No. You are dividing what by what? That's it. That's correct. Okay? Pretty much what you have in front of you. Not the density, though. Yeah. But you are going to want, I'm sorry. That, yes, you're going to want to know that. Grams per cubic centimeter. So one of the things you can do is, for instance, pick a transition metal out. That's a little bit of review from 2 years ago. What would be a good example of a transition metal? Iron. Okay, so element 26. So with that, okay, so how many protons does iron have? (26). Okay, remember the number of protons identifies which element you're talking about. So we say element 26, that's iron. Okay, so this one's 26. We're going to say this is 56. Okay, how many neutrons does iron have? 30. You subtract this number from this one, that gives you 30. Now here's the tricky part. +2 or +3? Because when you look inside your element box for iron or the one up on the wall, what else does it have in that box besides 26, 55.85, iron, Fe? There should be 2 other numbers in there. Okay, I didn't realize +6 was in there. So you need to pick +2, +3, or +6. Okay, so if this has a +2 charge, it's got 2 more protons than what it does electrons. So how many total electrons would that be? Is anyone confused over that? Okay, in other words, we know that there's 26 positive charges. Okay, so what are we going to add that has a negative value to get +2? That would be 24. So if you put 24 in here, this gives you a value of +2. That's where that number comes from. And on the other hand, who are the halogens on the periodic table as a review from 2 years ago? Do we remember by chance? Just guess. That's 1. That's 2. So where are you at on the table then? Column 7, that's right. So give me an example then of a halogen. Okay, so it's element number 17, right? Okay, so again, that identifies the element and we will say 35. So we're also going to say it's got a -1 charge. Okay? So, protons. What does chlorine have for protons? 17. Tells you that right here. On any element on the periodic table, the atomic number is the number of protons. Okay? How many electrons does it have? We're kind of switching this up. You notice we did protons and neutrons. Now we're going to do protons and electrons. The overall charge is what? So that must mean if there's 17 positive charges, how many negative charges must it have? 18. Because if it had 17, it would add up to 0. But it's got 18 electrons, therefore that's a charge of -1. Then finally, how many neutrons does it have? 18. Yep. This number subtracted from there gives you that. Okay? So those charges can be a little confusing if you rush through it, but it's something that you had done 2 years ago, and that's why at least we're spending some time on it now rather than throwing that on your evaluation on Thursday. I think that would that be awful? Just totally out of the blue? Urgh. Might turn into that green guy in the corner, huh? Right. Urgh. I was told by the seniors to say womp. Womp. Oh, I didn't know it was that prevalent. So I didn't even have to say it. You already knew that was their word. I don't know. They just told me to say. I did. I didn't know anyone caught that. I think that's kind of like in comic books. If you read some of them, they just got bam, snick, and what? Oh yeah, the words that sound like their definitions, like bees, bzzz, things like. I didn't know anyone knew what onomatopoeia was. Oh, okay. So if you know what onomatopoeia is, you should be able to write what a haiku is. I think it goes 3 different lines in the poem that add up to 17 syllables, something like. There's 3 lines to a poem. That's a haiku, something like that. So, just think the information that you learn that's not even related to chemistry. You get smarter in here. All right. So you've got a little, almost 20 minutes left. That is yours to utilize how you see fit. We'll catch up to you next time.